Hi everybody, this is Mr. Bradley, and today this is a video solution for trajectories problems 27 that is in your soft text. This problem is about a force used to launch a water balloon. So I have the problem highlighted here from the book, and I'm going to read it out loud. An average force of 150 newtons is used to launch a 1.2 kilogram water balloon into the air at an angle of 50 degrees to the horizontal. The slingshot is pulled back a distance of 2.2 meters, and it will exert a force on the water balloon over this distance. So the questions I'm asking here are, what is the velocity of the balloon as it leaves the launcher? What is the maximum height reached by the water balloon in its trajectory? What is the velocity of the balloon 3 seconds after launch? What is the horizontal distance traveled by the water balloon while in the air? And we need to assume that it will land basically at the same height that it started. So, I mean, basically, guys, in this problem, I'm giving you the force that acts on something, um, in which case you can find the acceleration and finally the final speed during the whole launch. That final speed will also be the VIXI of the water balloon launch. So in letter A, when I'm asking about the velocity of the balloon, I really am asking you for the final velocity here in this problem, just because I gave you all the information about the force to find that number. Once you know that final speed, you can call that VIXI, and basically you can do the rest of the problem based on that. So with that said, let's go ahead and get to the solution. Okay, so as always, I'm going to start off by drawing a diagram of the situation. Since this is really just an interval problem, I'm going to go ahead and draw a diagram for the force problem first, and then I will draw the trajectory problem. So in this problem, it tells you that a force of 150 newtons is acting on it. That really is meant to describe the net force that acts on the water balloon. So this net force is being exerted basically over a distance of 2.2 meters, at which point the ball will now have a velocity right here that we can solve for. Okay, or the water balloon, not the ball. And then finally, the last thing to do here is to say that the mass of the water balloon is 1.2 kilograms. By the way, that's a massive water balloon, just so you know. So I'm going to start off here by first calculating the acceleration of the water balloon while it's in the launcher, and then I will find the final velocity. So acceleration is found by taking the net force, which is 150 newtons, divided by the mass, which is 120 kilograms, and when I do that, I get 125 meters per second So it's got quite a bit of acceleration as it's being pushed with that launcher. So the next thing to do here for this question is to find the final velocity. Now, because I have the distance in this problem, I'm going to use the equation square root of 2AD. Square root of 2AD basically allows you to find acceleration or final velocity when you know acceleration and when you know distance. So when I take 2 times 125 meters per second times 2.2 meters, and I put that in my calculator, I get 23.45207 meters per second. Since this is really like a final answer for that first question, I'm going to go ahead and sig fig that and go with 23 meters per second. But again, when I go to use that number later down below, I will I'll go back to the unrounded value. So for letter B, now I'm into really like a trajectories question, because letter B and letter C and letter D all want to know about what happens after the launch. So now I'm just going to make a new sketch showing the VIXI as being 23.45207 meters per second. And I will solve everything about the trajectory from that. Hey, every trajectory problem, when you have VIXI like this, it really is going to be important to know what Vx and what Viy is. So I'm going to go about just calculating that right now over here to the side, because I know I'll be using that. Okay, so now that I know what Vx and Viy are, I can use those in whichever way I need to solve part of the trajectory problem. So letter B says, what's the maximum height reached by the water balloon in a trajectory? Maximum height is going to depend on VIY. That's really the thing that will determine not only how high it goes, but how long it will be in the air. So what I'm going to go about doing is figuring out what that maximum height is. Now, one really common way to do this would be to find time to the top first. By taking negative VIY over AG, and then I could use the time to the top to find the dy max by taking VIYT plus 1/2 AGT squared. And the time I'm going to be using here in this equation is time to the top, because that's really what matters. But let me show you, there's another clever way to find this, because you have an acceleration equation that depends on initial velocity, final velocity, and acceleration to find distance. And the key thing about this is simply when you shoot something up in the air and it comes back down to the bottom again, the final velocity at the top is 0. So knowing that the final velocity at the top is 0 actually enables me to use a different equation here to find distance. What I'm going to do is go distance is equals VF squared minus VIY squared over 2a, and the acceleration that I'll use is gravity. Because VFY is 0 and I know what VIY is, I can just solve for it that way. So I'm going to go ahead and do that right now. Okay, so after I calculate that on my calculator, I come up with a height of 16 meters, which is pretty high. This water balloon makes it pretty high up in the air, which I guess I would expect because it was launched pretty fast. Okay, letter C asks what the velocity at 3 seconds is. So basically what I'm saying here is, what is the velocity of this balloon 3 seconds after launch? I don't know where that is because I didn't find time to the top in the previous question. If I did a quick calculation of time to the top, I could figure out where this balloon is at 3 seconds. So let me do that right now. Okay, so knowing that it takes 1.83 seconds to get to the top of its path, I know that basically at 3 seconds, it's probably like right around here somewhere. Okay, this is where the water balloon is on its way back down to the ground again. And when it's on its way back down to the ground, it has a forward velocity, and it has a down velocity. It has a Vx, and it has a VFY. And those are the things that I'm going to find right here. That's really what I'm asking for. When I ask for the velocity at 3 seconds, what I'm really asking for is the final velocity in the x and y direction. So there's two equations that or actually one equation that I used to do this, because I already know what Vx is. Vx is 15.0747 meters per second. That never changes. VFY will be VIY plus AGT. The time I'm going to use here is just the time that it takes to get there, which was specified in the question. That's just 3 seconds. So I'll do that calculation here real quick, and then we'll see what VFY is. Okay, so what we know then is that at this time it's going forward at 15.07 meters per second, and it's going down at negative 11.465 meters per second. So now all I need to do is really combine those together with a right triangle and find out what the total velocity is. Don't forget, finding the angle is also part of that answer. So I'm going to do a quick calculation down here. We'll speed it up on the video so you can see kind of how this happens in short amount of time. Okay, so we find out that the velocity of the water balloon 3 seconds after launch is 19 meters per second, and it's going down a little bit. It's 37.2 degrees below the horizontal. Okay, we have one question left to answer. It says, what is the horizontal distance traveled by the water balloon while it's in the air? So I'm going to need to get out another piece of paper because this solution has taken up a lot of space. In order to find the total distance that it's traveled, I really need to know the total time that it takes to do that. We also sometimes call that the time up and down, if you will. If it lands at the same height that it started, then this will really just be 2 times time to the top, right? And if you remember on my previous page, I figured out the time to the top was 1.83 seconds. So if I take 2 times time to the top, then I will find out what the total time was. 2 times 1.83 seconds is 3.66 seconds. So that's how long it takes to get to the other side. What I'll now do is take the velocity in the x direction, and I'll multiply by that total time, and that will tell me what the total horizontal distance traveled is. When I find the velocity in the x direction from the previous step, it was 15.0747 meters per second. Multiply that by the total time that the water balloon is in the air, and I calculate an answer right here. That distance is 55 meters. Man, that is a long distance for a water balloon to be launched. I can tell you I sure wouldn't like to be standing over there and getting hit by that water balloon, because when it's coming in, it's going to be going super fast. All right, well, hey, I hope that this solution helps you understand this problem and other problems like this. Have a great day.